All right, new topic requires a new header. So, you could break your machine learning into different parts. Um, you could also have subheaders, load data. Maybe separate data for ML, right? So we've talked about this. So this is where finally what we're going to do is split data first into training and test set. Okay, it's the first thing we're going to do. And I say that because what we're going to do is we're going to use the training set to test like models and to try to like get the best one. And then at the very end, we're going to put it on a test set. Okay, so from sklearn dot model selection, import train test split. By the way, sometimes things change in terms. Oh, I just saw they were marking that dot. Okay, it went away. All right, so this is x train, x test, y train, y test, and this is going to equal train test split x comma. Oh, I haven't. I've done this often. I haven't set up x and y first. So I guess before that, I want to, determine. It's not determine. It's like it's another split actually, right? We're split data into. It's not the training and test set first. We're going to do that next into x and y. Okay, so x equals df.ilog. It's all we should double check. We don't want to assume, right? So if I go up to this data frame and I look at what am I trying to predict here? We've talked about this data set before. It's the count. Okay, we want to predict the total number of bike rentals in this one. All right, so that is the last column. So for my x, recall that x is it's all the columns that I'm using to predict the last columns. So it's all rows and all columns up until the last one, and y is simply the last column. Okay, so after I run that, now I can split the x and y, right? Otherwise I would get an error because I haven't said what x and y is. So I did check because this data set goes in order, and according to this, the sklearn model selection train test split, it is shuffled. So I'm just going to go with that and assume that that's true. See here, shuffle equals true. Okay, so going back to the data set, then I could go ahead and run this, and now I've split the data. So I'm going to go ahead and make a note here, all right, because this is important and we haven't really talked about this. We're going to basically hide the test set. We're not going to look at it, and we're just going to put it aside until the very end. What we're going to do is we're going to try to like tune hyperparameters and improve the model on the training set, which is what it's actually for. Okay, now we'll probably use a grid search. And so the grid search in itself will split the training set into 5 different folds into its own training and test sets, right? And the reason why we do this is because even with the 5-fold split, when your model is all said and done, we would have trained it on those 5 folds, okay? But what we really want to do is see how well the model can make predictions on data it has never seen before. And that's what the test set is actually designed for. So this is going to be our first time doing a double split. Okay, so we are going to leave x test and y test behind and only train on let's just say x train and y train. Okay, that's the way it should properly be done. All right. What do we need next? We separated the data now, and next it's time to tune the model, right? So let's call that something like fine tune ML model. Now I haven't made a baseline model yet, and meaning like I don't have a baseline score. So, sometimes I try to do things like a little more efficiently in terms of that. Um, what I mean is, like, do I really need to do like an additional? Well, let's just do it. Let's just do it the way we've done it. So I guess before fine-tune model, let's get a baseline score. Okay, so get baseline score for ML model. I was thinking you could actually use Grid Search CV to do that, but let's just get a baseline score. Right? We want to, before tuning, the idea is we want to see, well, how does it perform? Okay, so what we're going to do is we are going to use, cross-file score. Okay, so from sklearn, I think that's also model selection. Let's check, import cross-file score. There it is. We also want to do is this where the K fold is? Yeah, K fold. Okay. So recall that we use the K fold so that we can use the same folds in terms of both cross-file score and grid search CV. The way it's typically done is K fold, we're calling it this, equals, yeah, see, you see how they're underlining things squigglies? I don't like that. Sometimes they change things. We can do the K fold, and then you can look at what see, sometimes it gives you an indicator. It says of what you put in here, like in splits equals 5, and so it should be splitting the data. Shuffle is actually false. I think it shouldn't matter if we reshuffle it, but I think we could it doesn't really matter. Okay. And then the other thing is sometimes like in my case, I may forget, well, what am I getting the folds from? What it's not indicating in there, but it should be from the actual data. So I'm just going to try, right? Because it's not a model yet. It should be like, you know what? I think it actually does it later when you call it. So I think we can just use it like this. And if you ever wonder, you just type it in. Okay. What I mean is type it in Google search and we can check and see. You can also just run the code. Like sometimes if you run it and it works, then it probably, not always, but it's probably doing what you wanted. And then like basically it's set up a certain fold that we can then call. Okay. So again, to highlight this important point, set up K fold for same splits with cross-val score and grid search, which is coming later. Okay, but now the point is I can actually use this to, get a baseline model. So score model, let's do it. Okay, so we're going to use XGBoost. So from XGBoost, import the XGB. We want regressor because this is, many different points. And we can then like go ahead and get it. So cross-val score. And then in there, I want to put in, you can see, this is nice because like it's prompting me, right? I'm like, maybe someone else have done this. Well, estimator means model. So sometimes I would say model first, but you can also just put in XGB regressor. And then you've got XY. Now, this is very important. You want to use X train and Y train. Okay. Okay, so that's first. You can press return whatever you want to kind of make it more readable. So we've got two things. We've got scoring and CV. So for scoring, and I often forget what this is called, negative mean squared error, I think. I'm probably writing it wrong. I'll find out in a moment. And then importantly for CV, which is the number of splits, right? 5, 10, well, we're going to use K-fold. Okay. So, we'll come back to the error here. The scoring. So now I want to check, okay, if I do not know how this got up here. Sorry. I I don't even know what that was. So now, right, that's going to score these 5 models, but I want the RMSE scores. And so that's going to be, you know, I haven't defined it yet, right? I need to define it. I don't just want to see the 5 scores. So I'll just say CVS for cross-file score. Be more specific through variables. So it's the cross-file scores. What we want to do is we want to take the negative of them, okay? Because the negative will make it the positive. Turns the negative into a positive. We want to take them to the 0.5 power. And then, in effect, I just want 1 score, so I'm going to take the mean of those scores. Okay, so I can put all this in quotes and do dot mean. And then I can print RMSE. Actually, I combined steps. You can, you know, when you're coding, you basically have choice if you want to like define something earlier and then put it in, or like try to put more in one line. Okay, so let's check this. I get this warning. I forget about that. So I got his initial score of 627. That's good. So that's going to be hard to top. So it was negative mean squared error. I typed it in right. See, this is the thing. If I typed it in incorrectly, then I would find out it wouldn't run. So it says reg linear is not deprecated in favor of reg squared error. This keeps coming up. And so I think it's, I'm trying to get him to, yeah, objective equals. Okay. And then you just type in exactly what you see. Probably better to copy and paste, but squared error. Okay, let's see if that silences the warning. Yeah, I think I got the same score. It's worth knowing if you're getting the same scores, because no, they're a little bit different. And so this is where I think it can also be good. See, I feel like the cross-file score, it's a little much. If I just say model here, and then I put this in, but then I want to include like a certain level of, you know, I want to set the randomness, okay, for consistency. So the way you do that is you can set random state, and you can just pick any number you want. And I'm doing this to aim for consistency, right? Yep. Did not work. What did I put in wrong? Oh, I need to put, see, I redefined model, but I didn't put it in here, so model. Okay. Okay, I got 659.733. Now let's see if I run it again. Do I get the same thing? I do not. Wow. I thought that should do it because we're using the same k-fold. My understanding is that the k-fold is already defined here, but it could, Sometimes, you know, quirky things can happen with the random state, and it's actually not as important, really. And the reason why I say that is because when you do these multiple scores, it actually gives you a better idea of how the model's actually performing, because you start to see a range, right? It's giving 5 scores, but now it's giving like, you know, 5 different scores. So I can see like, does this also need a random state? Let's try that. So that might be the case. So it may be that when we call it here, it's going back up and it's like reshuffling. Okay. 646.4. I ran it again. 646.4. Okay, so you see it, that's how you can get consistent scores. Right? It doesn't mean that 646.4 is like, it's like more correct, right? It's just now that we have a set fold, we can move forward with this consistency to try to improve.